Hello everyone, welcome to my YouTube channel. Right, my name is Precious. So in this video, we'll quickly look at this topic, factors and prime factors. All right, and then so we're going to see what a factor is, and then what a prime factor is, how to find the factors and prime factors of numbers, and how to get the prime factorization of different numbers. All right, now this particular video is going to be very explicit in giving you all that you will need in terms of factors and prime factors, and then we are also going to deal with examples. Right. So, what do we mean by a factor, or when do we say that a number is a factor of another number? So, we say that a factor of a number is that number that leaves no remainder when it is used to divide another number. So, for instance, A is a factor of B. I'm using A and B now, they mean any number at all. So A is a factor of B if by the time you divide B by A, you will get a value without a remainder. Let's say K, for instance. Okay, so let's give examples. Now, for instance, now we know that 6 can be divided by 2, and then you will get 3 without any remainder. So you say that 2 is a factor of 6. And we also know that 3 can also divide 6 and to give us 2. Therefore, 3 in itself is also a factor of 6. And then there are other examples. Okay, so now what about prime factors? Now, for us to understand what a prime factor is, we would need to know what a prime number is. Now, remember that a prime number is a number that has only two factors. Only two factors. Okay, so there are numbers that have only two factors. And what are these two factors? One and themselves. Instances, we have 2, we have 3, we have 5. Now, of course, 4 is not a prime number because 4 can be divided by 2. The 2 is a factor of 4, and 2 is not 1 nor 4 itself. So 4 is not a prime number. And then we have 7, we have 11, we have 13, and etc. Okay, so now when we now see, now please note, you can see I didn't mention 1. Some people argue that 1 is a prime number, but of course it is not true. You know why? Even though 1 can be divided by 1 and itself, it didn't complete this definition. The definition first says that it has to have two factors, and 1 has just one factor, which is just what? Itself. So it only satisfies this part. It didn't fulfill the part of two factors. Okay, so now there are many other examples, like I said. So now, what is then a prime factor? So we said that a prime factor is just a factor of a number which itself is a prime number. So if I am able to list the factors of a number, for example 6, I list all the factors. 1, remember I said that 1 is a universal factor, meaning it can divide any number at all. And then you have other ones, 2, 3, and then 6. These are the four factors of 6. And so among these four factors, if you can list the ones that are prime numbers, for instance, 2 is a prime number and 3 is also a prime number. Therefore, what it means is that 6 has two prime factors. That means the factors of 6, which are prime numbers, are called the prime factors of 6. Therefore, the prime factors of 6, let me use PF for prime factor. So the prime factors of 6 are just 2 and what? And 3. Okay, so that's the meaning of prime factors. And of course, there are ways to find these factors and then also to find the prime factors. And that's actually what we call prime factorization. Okay, so we are going to see some examples quickly. Now, this one says we should express the following as product of their prime factors, right? That's the next thing we need to do under this. So, but before we get there, can we first of all see how to get the factors of these numbers? Okay, so for instance, I want to get the factors of this. All you need to do is just to decompose the number into its possible factors. For example, I want to get the factors of 18. So I'll begin with, remember what we did under divisibility. So the very first thing to do is to check the divisibility of that number from numbers between 2 and 10. So you can check 2. Of course, 2 can divide 18. And once you find the smallest number that can divide the number, use it and divide it and then split it into 2. It is going to split this into 2 factors. So you have that 2 is a factor and 2 divide this is 9. So 9 is also a factor. So I'm done with this. I come here. 9 is a bigger number now. So can I split it further? Yes. And then the number that can divide it is 3. And then when 3 divides 9, you also have 3. And then this other one, you can keep going until you get to 1. But of course, you know that this is a prime number, so you may not necessarily have to divide. But if you do, this will also give you 3, and then you get 1. So immediately you break this down, we call this decomposition into factors. So you will be able to list all the factors of 18 here. For instance, 1 is a factor. You first of all list all the numbers you find here. 1 is a factor, 2 is a factor, 3 is a factor, 9 is a factor, and 18 is also a factor. But are these all the factors that you have for 18? And the answer is no. Of course, you can find other factors by multiplying what you have here, except the one that you multiply that will be more than 18. That one won't be a factor. For example, if I multiply 2 and 3, I'm going to get 6. 6 is also a factor of 18. If I multiply 3 and 3, I'll get 9. 9 is already here. So I think it's only 6 that is missing. Therefore, the factors of 18 are 1, 2, 3, 6, 9, and 18. And that is your solution. Okay, so now if I want to find, for instance, that of 124, what am I going to do? Or let's do that of 110. Okay, so I'll begin with the first number that can divide, which is 2. Remember that 2 can divide a number if the last digit is even, and of course the 0 is even. So we have 2 here, then 2 into 110 is going to give us 55. Okay, so we're done with this. We'll continue here. What else can divide this? 5 can go there. Of course, 2 can no longer go here because this is not even. So, and 3 can go here because the sum is not divisible by 3. Of course, 4 can't go here because it can't divide the last 2 digits. These are things we have done under rules of divisibility. You might need to see that video. Right, so 5 can go here now, and 5 into 5 is 11. And then lastly, of course, this is a prime number. You can also stop here. But if we go further, we are going to have 1 here. So that means we can list all the numbers, the factors here. The factors are going to be 1, 2. Next question again is, are these all the factors of 110? And the answer is no, because we can still multiply. 2 times 5 is 10. And of course, 10 can divide this. What about this? 5 times 11 is 55 is already here. What about 2 times 11 is 22? Can 22 divide this? Please take time and check. Of course, 22 divide 110 will give you 5. So it is correct. And then what other thing can multiply? What about if this one multiply? That is 11 times 11. It's already giving you something more than 110. And so that means the factors we are looking for are 1, 2, 110. So one thing you would notice about listing the factors of a number is that it will always give you an even number. So you can check here we have 1, 2, 3, 4, 5, 6. Here we have 8. So it will always give you an even number. The reason is because every factor has what it will give you. That's the dividend. So for instance, if 1 divides, it will give us 110. If 2 divides, it will give us 55. If 5 divides, it will give us 22. And if 11 divides, it will give us 10. So it will always be even because there will always be a pair. Except when you have a kind of a number where 1 divides to get itself. For example, 9. Okay, so you can see if you list 9, 1, 3, and 9 itself, these are all. So you just have only 3. The reason is because 3 divides 9 to get itself, and so it's going to give you an odd number of factors. Okay, so and this is where I'm going to stop for factors. I would like you to look at the other two, that's the factors of this and the factors of this yourself, and let me see what you have. Right now, how do you then get the even, sorry, the prime factors? Okay, so let's quickly look at prime factors. Right, so there are two ways we can get the prime factors. We can either use this approach. That means after we have decomposed it into all the factors, we just pick out the prime numbers there. Like here we got 1, 2, 3, 6, and 9, and then 18. So we just pick out the prime numbers, which are just these two. Okay. Alternatively, which is actually the easiest approach, all you need to do is you do a long decomposition of the numbers. In this case, you're going to just be dividing by only prime numbers. So here I'll start with the smallest prime number that can divide 18, and that is 2. So 2 will divide 18 to give me 9. So I'll look for the next prime number that can divide 9. Of course, 2 can't go again. The next one is 3. 3 into 9 is 3, and 3 into 3 is 1. And so among all of these, you just pick out the numbers that you have here. Of course, you can't repeat 3 now. Therefore, the prime factors of 18 are just what? 2 and 3. So what you would have done here by listing everything and then picking out prime numbers, you can easily do it using this approach. For instance, if I want to get the prime factors of 336, so I'm also going to divide now. 2 can divide. You see, this is why the rules of divisibility is important. If you have not seen that video, please kindly take time to do that. So I know that 2 can divide this because the last number is even, and so 2 into here is going to give me 1. 1 here is 13, that's 6, and then I have 16, which is 8. And then 2 can still go again. Then I'm going to have 8, 4. 2 can still go again. I will have 4, 2. 2 can still go again. I will have 2, 1. 2 can no longer go, but 3 can go. 3 into 21 is 7. 3 can no longer go. 7 can go, so I have 1. Now recall that you keep doing this division until you have 1. So when you have 1, just look at the digits you used to divide. And here we have only 2, 3, and 7, and these are the prime factors of 336. Okay, so and now having seen how to get the prime factors of numbers and all the factors of numbers, let's now quickly see how to now get the prime factorization, or the expression of numbers as product of their prime factors. That's what we want to quickly look at now. Okay, so we begin with these examples here. So it says we should find all the express these numbers as product of their prime factors. So for 18, you just do exactly what I did there. Maybe I shouldn't have even cleaned it. So this is going to give us 2 here is 9. 3 can go now is 3. And finally, you have 3, 1. Therefore, if you want to express 18 as a product of its prime factor, it's just going to be 2 times 3, sorry, 2 times 3 times 3, and that is your solution. So you can see that this product is actually equal to 18. And then there's also another way we can see this question, whether in WAEC, junior WAEC, or even the senior. So we can ask you to express this in index form. So we can put this in index form, and that is 2 multiplied by 3 raised to power 2. And of course, they are the same thing. So for number 2, we have also done this one. In fact, let's go to number 3. I will allow you repeat this again and then give me a solution. So for this, we got that, or we have that 2 into this. 2 can go, yes. That's 6, 2. 2 can go again. That's 3, 1. 2 can no longer go. 3 cannot go. 4 can go. 5 can go. Of course, 31 is actually a prime number. And so 31 into 31 is 1. Therefore, our 124 is equal to 2 times 2 times 31. That is the expression of 124 in, sorry, as a product of its prime factors. And if we put it in index form, is 2 raised to the power of 2 times 31. and that's your solution. For example 4, we have 110. Of course, 2 can still go again, which is going to give us 55. 2 again, sorry, 2 can no longer go. What else can go here? We already did this, and that's 5. 5 into 55 is 11, and 11 is a prime number, so 11 can go. Finally, our 110 is equal to 2 times 5 times 11, and that is the expression of that number as a product of its prime factors. Okay, so finally I will do 5 and I will allow you to do the sixth one. Okay, so what do you do here? Okay, so here I'm going to have my 1008. Okay, so all of these they are divisible by 2. So 2 can go here to give me 5 here, 0 here, and 4 here. 2 can still go here, and then we're going to have 25, 2. 2 can still go because this is an even number. And then I'm going to get 2 into 2 is 1, 2 into 5 is 2, carry 1, that's 6. 2 can go again, 6, 3. 2 can no longer go, but 3 can continue. Or let me do this way. 3 into 63 is going to give us 2, 1. 3 can still go. We get 7. 3 can no longer go, but 7 can go. So we have 1. Therefore, our 1008 is equal to 2 multiplied by 2 multiplied by 2 times 2 again, then times 3, and finally times 7. And in index form, that is 2 raised to the power of 4 times 3 raised to the power of 2, then times 7. And that is our solution to this. So, and like I said, I'm going to allow you to take care of this, and please put your solution in the comment section. This is also an exercise for you to see. Right, so what did we see in this lesson? What is a factor of a number, the meaning, what is a prime number, what is a prime factor, and how to find the factors and prime factors of numbers, and then how to do the prime factorization of numbers, which is the last examples that we did. If you have any question, you can always raise them on our comment section. And please kindly subscribe to our YouTube channel. Please do like, share, comment, whatever is a case or that you want us to look at. And we'll see you in our next video. Bye.